So today we have with us Dr. Mark Changizi. He's a theoretical neurobiologist, cognitive scientist, writer, and author. Mark got his bachelor's in physics and math from the University of Virginia and his math PhD from the University of Maryland. He has since then started his own research institute called 2AI Labs and has written several books. He has made important discoveries such as why we see in color, why we see illusions, why we have forward-facing eyes, why the dictionary is organized as it is, and where emotional expressions came from. Mark, it's good to have you here today.
Great to be here.
So you started out as a math PhD, and now you're working in the biological and cognitive sciences. How does one make that leap?
Well, I mean, if you go back to ever since, fifth grade or whatever, elementary school, in my generation, Carl Sagan, which you've heard about probably, but it was a pretty big influence on a bunch of us of my generation. Even I met folks in Spain in my generation that were really affected by him. So one of the nice things about Carl Sagan was that he motivated science in a very almost spiritual way, almost like a religious way. So it tapped into some of those deep, why is there a universe at all kinds of feelings. And if you try to motivate physics and science on the basis of, well, it'll help you fix stuff, that's not really that motivating. That's going to push you your whole life to try to make discoveries. But that kind of more spiritual, and scare quotes, way of talking about physics, and he had this little silly spaceship he would travel the universe through and just talk about how deep, all the deepest kinds of questions. That's what motivated me in life, to sort of aim to answer the questions to the universe. And that's sort of purposely vague, because what it means, depends on, varies from person to person. But then in high school, my letters to undergrad were in fact roughly the following plan. I'm going to go to undergrad and or PhD and get physics and math so that I can go back and study cognitive science, biology, brain. And I said a lot of stuff about consciousness, which I think it's a pseudo problem. But anyway, I was like, how can you get all these atoms suddenly have self-awareness and all? So these really deep questions. But in order to be good at those things, my feeling at the time, and I feel like I was right, is that you have to know physics and math and these fundamental computational physics, these kinds of technical things that are really key to make discoveries in those fields, rather than going directly at it. So it was on purpose in some sense. So it wasn't like I was in math and decided to go the way. That was all by design. I wanted the PhD in math, not so that I could fuss around with theorems and tautologies for the rest of my life, but so that I could go back and try to, just find whatever I thought was the most fundamental problems and tease them apart and have the rigorous background to really do that.
Do you find that you use some of the things you learned in your PhD in your daily research?
Yeah. So, all the time at various stages, I've had to utilize either specific skills that I learned even within physics and computation and math. And often it's the general kind of rigorous understanding, so that, if you really want to create if you're a theorist like me, you want to ground things out, and you need to know what it means to ground things out into fundamental things that are sort of the starting point. Like probability distributions are a good starting point. If you don't certain kinds of things are the right places to start. And if you have no idea about that kind of richness within those worlds, you don't really know how to build a rigorous theory, or even what a rigorous theory would mean that can make suites of predictions and so forth. I also, by the way, spent a lot of time in philosophy. I was thinking of getting my PhD in philosophy, and I spent a year just studying philosophy. And I decided ultimately that I was more of the Carnap, Quine, Hilary Putnam kind of, Bertrand Russell kind of philosopher to begin with. But ultimately I decided, both for life wisdom sorts of reasons, that it's better. You don't know how your career is going to go. You don't know whether some pandemic is going to hit and the whole world's going to go crazy like we are. You want to have a degree that's often has some resilience. So between that, but I do consider myself more of a philosophical scientist, in that I'm always trying to think as holistically as possible to understand the deep issue at hand, rather than trying to build incremental. I've never been interested in building incrementally. So if there's other people that can do, if they're interested, can do that, that's not what I'm good at yet.
I think that's fascinating. I think a lot of the way that science and academia works now is that we're so stuck in our little categorical bubbles where everyone's in like their own line, studying their own thing, and we don't really read each other's research. So I guess it's good that you have your toes dipped in many lakes, kind of. So since you've had a lot of experience working in so many fields, and you've had many things that you wanted to do, like you just said, you wanted to study philosophy, but then you sort of didn't do that, and then you're doing math, and now you're doing cognitive science. So if you could turn back the time and talk to your 18-year-old self, freshman in undergrad, what would you tell him?
Well, I'm kind of happy with the way that I did. There could be some, particular. Don't go. Don't be the. Don't do a postdoc under that guy. There could be some particular things, but the idea of this, the steps that I went along, um, uh, I, I feel like are the kinds of the basic philosophy is still right for the kind of aim that I had in life. My own son, my daughter's 18 actually, and my daughter, they could, we'll see where they're interested. To the extent that they're interested in that, I've been advising one of them to maybe aim in a similar direction, try to stay aloof in some sense, and really widespread, so that you're always free to move in directions that are crazy directions, and you're not sort of psychologically have the illusion that you're being creative in creative new directions, but you're really been confined your whole life within one small area, and it can be easy to let that happen.
So I know that you mentioned before that you worked in academia in the beginning, and it was kind of like a crutch for you because you didn't have the intellectual freedom. Because typically, what happens is that people just sort of look for grants and stuff, and you're kind of an instrument of the university. So, what made you want to leave that?
Yeah, it's bad enough as an experimentalist there, and 99.9% of scientists are experimentalists, because in some sense, to survive in academia, or to be rewarded in academia, not to survive, but to be rewarded and sit next to invited to sit at parties next to the president of the university, it's because you brought in the $3 million grant. And if you're bringing in big grants, it's because you've proposed to do 3 years or 5 years worth of experiments. You can't propose to do 5 years worth of thinking and maybe nothing will happen at the end. Like, so even among them, it becomes a game, and it can be a mind-numbing game, even if you win, or especially if you win, because you'll start grant shopping. You'll just start looking through. Yeah, and you're still doing your same hammer, and you're just trying to hit everything in some other angle and claim that you're still doing that, rather than working on whatever romantic thing originally had inspired you, which is often 20 years gone by then anyway. It's been beaten out of you by then by your first advisor in graduate school, who you didn't even know what you were getting into, and you picked it only because they accepted you to the lab. And then you go to the postdoc, which is the cousin of your graduate student advisor, and your first job is sort of basically because you were in those labs, and your first grant is because you're going to do the same dang thing somehow related to what they did. Time very quickly goes forward. And if you're a theorist like me in a field, even in physics, there's very few theorists. It's, the relative fraction of theorists to experimentalists has got to be 1 in 1,000 or so. And in neuroscience and cognitive science, it's very, very rare to have a theorist at all. Often there's sort of theorists who are maybe working with experimentalists to try to decode, or in some sense analysis sorts of folks, but they're not sort of these large scale theories like I like to focus in. So it would be very difficult to get grants. I was able to get grants in those things, but often it just felt like this is not where I would want to stay. And to the extent that I can start winning here, it's going to be because I'm crushing my creative directions and freedom. So much of my career has been designed at maximizing what I want to work on and maximizing my intellectual freedom at all stages. That's sort of driven my approach. Yeah.
So your work as a theorist, like you mentioned, is kind of you're kind of a minority, right? Given that everyone kind of, like you said, needs to be experimental in a way to make it big in academia. And a lot of scientists try to figure out the how, right? The how the mind works. But you're taking it in sort of a almost teleological way, right? You want to know why it works. So what made you want to take the more theoretical, a priori kind of approach? And why do you think most scientists choose to live in the sphere of the how?
Well, there's a number of, one is, I think there's personality difference between some folks. A lot of people go into physics. There's two physics kids, I used to say. There's the Carl Sagan kids for my generation, which doesn't necessarily make sense in your generation. Although the new Carl Sagan show was great. The new Cosmos show was great, by the way. It was good. There's Cosmos kids or Carl Sagan kinds of kids, and then there was like the kid that took apart their radios. And I think that they're motivated to go into these sort of areas for completely different reasons. Kids that take apart their radios are interested in how things work. Obviously, they're interested in the engineering principles as well, but they're, I think, much more interested in really the how, which billiard ball hits the next billiard ball, and the sequence of things. And I would imagine that could be true across the sciences more generally. A second reason is just because it's not rewarded. It's selected against because if you're going to get a grant, you have to propose either to build something, more engineering kind of stuff. We're going to build this particular kind of thing, or we're going to do an experiment. And the system selects for those two things. 3, within neurosciences and biological sciences, even though they all believe in evolution, they believe in natural selection, if you hypothesize about natural selection, I don't know if you can hear that. I've got a parrot in the background far away. He's screaming right now. He's in screaming mode. If you actually make hypotheses about natural selection, it's considered a just so story. This has almost became a political issue 30, 40 years ago with the sociobiologists, E.O. Wilson, and then it became another kind of political issue in evolutionary psychology, capital E, capital stuff. I'm not an evolutionary psychologist, or the term of art, the kind of evolutionary psychology they do. So for almost reasons that you can barely comprehend, but they somehow go to left-right reasons, which there's no people who are even sociobiologists that often were far left folks, but for whatever reason, it tapped into some strange anybody who tries to do anything that's about the design is accused of just so stories. And just so stories is a reference to just so stories by the great author, early 20th century author. I'm having a mental block. Who's so like, how did the elephant get his trunk? And there's some story about a crocodile pulling in some other kind of animal that got long. And so it's just like bullcrap stories that are fun and they're great stories, really well written. And a lot of stories about natural selection and evolution historically were things that people would write in the conclusion section of their otherwise reasonable paper. And it's sort of spinning stories. That's not how you test hypotheses within evolution. If you're going to test hypotheses about a design, you have to do it's a different way that you go about testing. So they can be just so stories, and you can have just so stories about mechanisms as well as about the how. Just for example, the fact that you get pruny fingers for 100 years, it was basically just like a bullcrap story. It's like, well, it gets wet in osmosis and some kind of waving your hands that it gets pruny for that reason. There was never any good argument that even made sense in it. So, because when things get wet and they swell up, typically things get less wrinkly, not more wrinkly when things swell up. So it didn't make sense even on its own terms. So why am I interested in those sorts of things? I suppose I'm interested really to design I'm interested in why things are designed, what the designs are for the first thing, and then why they're designed that way. And much of what's in biology, we're teeming with design, filled with design, most of which we don't know, because it's incredibly difficult to sometimes understand those designs, because there's no book written like, Terminator, the robot from the future. Somewhere back in the lab in the future, the AI folks who built him, or the first humans that built him, I don't know who built whatever. Probably there's some little book that says, okay, there's just some massive list of functions of what each different part of all the different software capabilities that it has and has been written into it. We don't have that. Not only do we not have, that's a notoriously difficult thing to do with software. Once software is written, not to mention once it's compiled and you're looking at the compiled code, it's practically impossible to understand what the heck the code was. And even if you have an average bloke's code and it's 100,000 lines long, and even if it's documented, it can be practically impossible to figure out what the heck is going on without the actual documentation. I mean, like the outside, an actual book that's written with good prose, it's practically impossible. Figuring out what these things like us are designed to do is exceedingly hard, and a lot of them are most amazing powers that we do so easily. We do it all the time that we don't notice them. We can't notice them because they're just too easy. So much of AI historically is focused on the hard things for us, like playing chess, whereas all of the easy things turn out to be all the hard things. Is roughly a one sentence history of the last 50 years of artificial intelligence. Is all the stuff that we thought were easy. We either didn't even say that it was a problem at all because we didn't notice, or we realized, okay, that is something you have to do. And it turns out that's the hard stuff. And the hard stuff turns out to be not that hard. for other creatures to do. Yeah.
Speaking of AI, do you ever fear that AI itself could be a threat to humanity itself at all?
I mean, no, I guess not. I mean, anything can become a. I mean, I'm a creative person. I can imagine stories, where anything can become a threat. Um, pickles. If you overgrow pickles, you can have too many pickles. It can cause a threat to. You can create a story. But no, I'm not one of these folks that thinks AI is on the cusp of anything. I'm working. They're. What makes us smart, what makes you and me smart, is really our emotional intelligence, and the intelligence that Data from Star Trek, if you even ever watched Data from Star Trek, but he was the most interesting character because he's sort of always trying to be human, always, and he's super smart in the intelligence IQ Spock-like sense. But each episode that he's involved with, the moral in some bigger sense is that no, he's actually really stupid, because all of that billions and trillions of calculations that he can do really means nothing when it comes to the common sense stuff that we take for granted. And what makes us, in fact, smart is our socio-emotional capabilities, which is the emotional expressions that we do and what it is that we're doing when we're doing these things. And then my next book is called Unmasked, sort of like the Rosetta Stone of emotions, unpacking what emotional expressions, in fact, are. And really what they are is poker. When you and I are expressing ourselves, even in English or whatever language, we're putting in emotional expressions in our words. We're doing with intonation and other kinds of things in the sound of our voice, and it often is basically like a poker game. I might be trying to say, look, do you know who I am? Like concerning some argument that we're having. If I suddenly say, do you know who I am? What I've done is I've taken a whole lot of chips. In this case, the social capital chips, not currency, not like dollars. I've shoved those chips in. And if I do that, because you're a student right now, you'd be like, crap, I can't even, you're right. Suppose in this case, you're actually right. Or you're 99% sure that you're right, but you have to be respectful. You're like, okay, you just back down because I've put in so many chips. I'm a chip bully. And you don't even have as many chips as I have at all, which happens in poker. The guy that's sitting there with a big pile of chips, he's a chip bully, just pushes everything in. And everybody else is like, yeah, to even match, I risk going out, I risk losing the whole. So it turns out that emotional expressions are in fact playing a kind of poker game using reputation chips. And you can actually work out sort of fundamentally from first principles exactly how it works. And then it explains why we have the emotional expressions we do. Poker is one of the most complicated games on earth. Chess isn't that complicated. All of these other things that we think are complicated in a very narrow kind of more autistic Spock-like sense. And we already have algorithms that can beat us in those things for some time. Poker with unlimited raises, where there's no limits. Poker, there's no one that can, no programs can beat the experts in these, and it's still not well understood how it works. So this is the realm that humans are good at, and all social animals are good, and humans are especially good at. And AI, I'm working on technology that's trying to bring, once we understand this, understand that's a kind of poker game, exactly how it's working, then you can start to ask whether AI can actually do the smart things. So could it eventually become smarter than us? Yeah, I suppose there's no reason why. Eventually it could be smart enough that it, wins the girl that you've been trying to date because it just pushes you out socially, marginalizes you. That's the kind of AI you'd have to worry about. So I think we're probably getting closer to that, but it's still a long way off.
All right. Makes sense. So I know this from following you on social media, but for those who aren't aware, you're a pretty big critic of lockdowns and the conversation regarding the memorialization of masks. So what's something that people seem to misunderstand about you?
Oh, so about me or about, so you said about concerning COVID hysteria, and then you said misunderstand about me.
I mean, so about your stance.
General question about me and a misunderstanding about me overall?
About your views on the topic.
Oh, on that topic. Oh, I see.
Yeah.
Yeah, no, I don't know of any large scale misunderstanding. I mean, you always have the people that from the very beginning, you'll argue against lockdowns or arguing against masks if they don't work, or like my son hasn't seen his friends in 6 months, and they'll say, well, what, my son would really like to see his friends, and they'll say, well, why does your friend hate old people? I'm slightly exaggerating, but why does your your son or you want to kill old people. And there's of course the other side, the side that's arguing against these things is being radical, astronomical exaggerations of the truth, and misunderstandings of any sense of proportion and comparisons to what happens. So the other side has become so single dimensional. It's just minimizing the death of one kind of virus at the expense of everything else. And so I suppose that, if they're misunderstanding things, the real argument is that no, you have to, as always, you have to look at the whole spectrum of risks and benefits, do a full utility calculus, and at all times try to get some sense to which the social media and government is hysterical. And you can sometimes, I feel like people have to build their own antennae, which sense the extent to which, no, this is like a weird crowd thing that's going, like a mob-like behavior, and try to control for that. So there's something true about what they're saying, but I think it's radically exaggerated, and go figure out what's really going on, because these things happen all the time. It happens all the time on the left. It happens all the time on the right. And I used to complain all the time, like, the people on the left, the people on the right are not all evil racists. The people on the right, the people on the left are not all this, right? But now I was so frustrated with the kind of mob behavior that happens when people. But now I'm happy that the world was such that there was a left and a right balancing their crazinesses. It creates two crazinesses in some sense is great now, because now we end up in the world for the first time where the entire world became all in one swell beating, saying, oh my God, this thing is coming at us and it's all going to kill us. And they all were saying the same one crazy thing. And there was basically no balance. And in March, I was screaming out. I was like, what the fuck are you guys doing? You can't do this. This is like, you can't just stop. There's no such thing as freezing an economy. You got to keep going. Otherwise, there's secondary and tertiary, and all of these steps down line, the developing world is going to be crashing. Like, do you not realize that these things are all connected? And it's not even nearly as dangerous as you're saying. It's like a bad flu if you're old. Like, none of it made sense, right? And so this kind of whole world. I mean, I come from Iran. I was born in America. My dad's from Iran. My wife's from Iran. They left a world that was like this, and there's other parts of the world over different parts of the time that have dealt with this. And this is a great experience for the West, because usually the West, I mean, of course, this happened in the West. I mean, Nazi Germany was another case. But roughly speaking, we kind of look at these faraway countries and say, yeah, but they were Muslim and they're Middle Eastern, or they're weird. They're different than us sufficiently that would never happen to us. And we have this nice democratic, principles loving, civil liberties friendly. And no, civil liberties were thrown under the bus immediately. In fact, by all the civil libertarians that I followed, they were the first ones to jump on board and saying, everything has to be thrown on the bus, and we have to be like China times 10 immediately. So all with one, and the most dangerous part wasn't even that. It's just the fact that it was everywhere, everyone with one view. And that was the scary thing. And it's still the scary thing about this.
Exactly. I think when you start to talk about issues like this, one side always manages to shift the goalpost and say, no, it's this case or this case, and sort of to bring exceptions to every good example that you bring. And I think that doesn't allow for productive discourse.
Yeah. Well, it's one way to think about this. There's a couple of different ways of modeling or thinking about what's going on. One kind of reasoning that people do is called Bayesian reasoning. It's a model of how people reason. And Bayesian reasoning just means that, when you see evidence come in, you modulate your hypotheses, or the degree to which you believe hypotheses, on the basis of the new evidence. But the question is, before you had any evidence, you have something that's called a prior. It means a prior probability distribution over the hypotheses. So in the absence of anything, you might start with a flat prior over, let's say, on a coin, you might say it's it could be a lot of probability that's 50-50, and a very small probability that's it's biased, or maybe it's a trick coin. So you give a little probability that's a trick coin, all one or all heads. But lots of different situations will have some kind of prior that's not based on evidence. It's based on something else beyond the evidence. But anyway, once you start developing, evidence comes in of various kinds. Sometimes the prior becomes what's called a posterior. It changes, and it just changes over time. And so if, for just as an example, if for some reason I trick your brain into thinking that 99.99999% of the weight in this distribution of things should go on one particular hypothesis, H3, some kind of H sub 3 should have 99.999%. if I trick your brain into having that, and then I take the spell off, you still have that, but now you're going to behave rationally from then on. Even if you're rational from then on, all the data that I give you is still going to be, you're still going to be concluding that H3 is the one that you should believe, because it started out with almost infinite weight relative to the others. And you could still be rational for a whole generation, subsequently rational. There was this one moment of irrationality, and subsequently you can be totally rational and still completely disagree with another whole camp who never had that little spell that was put on them. As opposed to a model where you imagine that they're still irrevocably irrational. They're not. They were just one moment of irrationality. And that moment of irrationality happened in early March when the hysteria happened, and when everybody hears from the mainstream media one thing, super dangerous astronomically thing that should be life-changing, all of their friends, every person that they've ever known, the government is saying the same thing. When you hear it from that many sources, and it sounds like that many independent sources, because I mean, your brain probably treats it as independent sources, which provides a lot of support. Whereas if your brain could say, oh, that's basically just, that's really just one person saying it, because they're all saying it's all coming from somehow the same place in a feedback loop. But that's not what your brain thinks. It's like this many independent people telling me. So that amounts to evidence because people are telling you stuff. And so I think that what that happened is it just, the whole world's priors, or, the probability distribution got really, 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 really biased. And as rational as they are, it's too late for them. You can't undo that very easily. So that, I mean, that's one way to think about it. So people like me, we feel like we're just batting our head against the wall, because you can't, it's practically impossible to undo that.
So before we sort of close out, I'd like to ask all my guests the same question, and that's, what's your favorite quote? This could be something that you live by, or something that's close to your heart, or even some words that you're really thinking about nowadays. Do you have something like that you'd like to share with us?
Oh, favorite quote. I'm not good with remembering trivia or specific things like that. That's not my thing. Yeah, I mean, but as a general kind of getting back to the sort of bigger picture in terms of undergrad, and I'm not sure if I have a quote for you, but I'll just leave you with a quote. I would just aim, the most important thing for me in life is making sure that your projects, you aim for great projects as far as you're concerned, and follow your dream. Just these things are I think some of the most important things to think about is, to design your life such that things don't get in the way, because soon things are going to start getting in the way.
Dr. Mark Changizi.
Nothing as eloquent as you're hoping for.
No, it's great. It's great. It's good advice for undergrads. Dr. Mark Changizi, it's been wonderful talking to you. It's been an honor.
Great to be here.
Thank you.